Welcome everyone to the session of the European Big Data Value Forum on next generation computing infrastructure to support data spaces. Thank you very much for attending. My name is Giovanni Rimassa. I am Chief Innovation Officer at Martel Innovate, and I coordinate the Horizon 2020 Hub for Cloud Coordination and Support Action Project. And we are working in the area of European cloud computing to gather and manage the community of research and innovation in this area. And we have organized this session within the EBDVF. And without giving you too much detail about the Horizon Cloud Initiative, I would just like to remind you that we will post on the chat the relevant links for the project and other interesting information during the session. And you can also interact by writing in your chat window in your B2Match session if you have comments or questions, and we will pick them up and submit them to the speakers. The structure for this session is a panel discussion, so please, next slide, thank you. And my colleague Amrita is managing the session, and she will also take care of getting your questions from the chat for our panelists. So I am the coordinator, the moderator here, and I just quickly name the panelists, and then they will introduce themselves and make an opening statement to connect the, let's say, the requirements, the topic of international data spaces with the constraints and needs, the disputes on the computing infrastructure when we move from cloud and IoT separate domains towards what is now called the computing continuum that will cover all the cloud, edge, and IoT configurations. So in no particular order, I will start with Ulrich Halle, the CEO of Fiverr Foundation and a member of the board of the International Data Spaces Association. Welcome, Ulrich. Then we have Andreas Weiss, head of the Digital Business Model Unit at the ECO Association of the Internet Industry Director, and also member of Gaia-X Technical Committee. Welcome, Andreas, as well. Then we have Roman Dumitru, Senior Research Scientist at SINTEF. Welcome, Roman. And we have then Enric Pages from Atos, in particular for the unit that deals with new media and edge software technologies. And last but not least, we have Eduardo Quinones. He's a researcher at the Barcelona Supercomputing Center, and he represents, and the Supercomputer Center is member of the CLASS project that belongs to the Big Data Value Association project pool. So welcome to every panelist. Thank you very much. And I would then start, as I said, with Ulrich. So if you can make an initial statement on the connection between the IDS, the data spaces vision, and what we need to do in the computing infrastructure to support this vision and to make it reality in Europe.
Mm-hmm. Yeah, Giovanni, thank you very much for the invitation and introduction, and a very good morning to all of you. I'm representing here on the one side as board member of the International Data Spaces Association, as well as CEO of the Fiverr Foundation. Two of several players in the area of the future cloud infrastructure. And for this, it is very important, as today a lot of this cloud computing is done really in the cloud, and we see a clear trend that more and more computing power, more and more intelligence is moving from the cloud down to where the data have been created. So that's what is called down to the edge. And here it is important that we create this, Giovanni, as you mentioned, it's this continuum between edge, far edge, near edge, IoT, cloud, and find the best place to bring the intelligence, to bring where to operate the data, where to create new information out of the data, and to create the basis for smart solutions. Because that's finally the idea of the cloud infrastructure, of the federated cloud infrastructure, to make data accessible and to use this data for intelligent and smart solutions to, on the one side, improve the quality of life of people living in the city, of workers working in a factory, of people working on a farm on the other side, on the one side, and on the other hand, to reduce the cost of operating such organizations, of operating a city, of operating a company or a farm. And here the activities we are doing all together in creating this cloud continuum will help us and will push also verticals which so far are hesitating to use such services. For example, the public sector. In the public sector, a lot of computing is done still on premise, and the benefits of cloud and the cost benefits, the flexibility benefits of cloud and edge-based solutions are not really gathered. And here I see really a large potential, but it is important that we join forces and work together here.
Thank you very much, Ulrich. And I would now hand over to Andreas for the second opening statement before we move on.
Yeah, thank you, Giovanni, and good morning, everybody. Well, as Ulrich already outlined, it is very important to get hold of data to build up all these new emerging concepts around smart cities, smart mobility, and so on. We have this cloud adoption already mainly, and we are also identified the need of edges. So we are targeting a kind of distributed computing environment, mainly crossover Europe. And in parallel, we have the application of AI, for example. So this is one of the processors of data, which is very important to drive innovation. And bringing all these together, I think Gaia X, and I'm representing here Gaia X as member of the technical committee, and of course ECO as a representative for the internet industry to support also the infrastructure layer. And this is the twofold approach of Gaia X, to have a combined view of data ecosystems, really about data spaces and smart services. And on the other side, we need this infrastructure layer with the cloud computing processing, the edge computing, interconnection, high performance computing. And therefore, Gaia X stands here to build up a kind of orchestration layer. So Gaia X addresses the implementation of an overall architecture for building data-driven services and business models, of course, with highly distributed system and entities that, and it should eliminate dependencies on single providers in the same time and allows data sovereignty, because these were some of the key concerns when we adopt such new digital services and build up data spaces. It is always a question, am I still the sovereign of my own data if I'm going to share it with other parties? And this is far beyond the GDPR consideration, of course, because even technical data is to some extent intellectual property of those who are owning the data or producing the data. And therefore we need this approach. And beside this, it's also very important to guarantee data availability. So if you build up a business model based on data, you need a full clarification. Who is responsible to provide the data on the provider side? What are the usage policies behind it? These are all the terms which are already mainly addressed in the area of data spaces. In parallel, we have to consider various formats or concepts like computer data and data to compute. So we have to bring this all together. And with Gaia X, we are going to establish a kind of conceptual model, but also an organizational model with all the key components to address these key objectives in terms of data availability, data sovereignty, and to drive innovation. And I think this is a very important journey, and it's very good that we have the alignment with all the other stakeholders like IDSA, like FireWare, BDVA, and so on and so forth, because now it's the time to bring all these things together. It's not to invent something completely new. It is more to orchestrate what is already out there and bring it into a good and stable and mature environment. So this is the mission of Gaia X at the end of the day. Thank you.
Thank you very much, Andreas. And now next is, if I'm not mistaken, Roman, right? So floor is yours, Roman, for your opening statement.
Sorry.
Yeah, you're coming. Yeah, very good. I can see you now. But you're still muted.
I'm sorry, it's a lot of noise here. Can you take me last one in the session?
Okay, yes,
Sorry,
no problem. So then I move on to Enric, please. Enric from
I can continue, no problem.
Thank
can
you
you
very
hear
much.
me well?
Yes, I hear you very well.
Okay. Good morning, Giovanni. Good morning, everyone. I'm Enric Pagès. I work for Atos within the Research and Innovation Department, located in Spain. More precisely, I belong, as you say, to the new Media Edge and Software Technology Unit, where we contribute to Atos' strategy with regards to the edge and cloud computing and its novel forms for the development of the next generation of cloud and edge solutions. As part of our research roadmap, we are working on decentralization, over distribution of computing, over edge, multi-clouds, and hybrid cloud environment as well. We are working on improving quality of experience and automating SLA negotiation. In addition, we are also working in benchmarking and automated service adaptation, taking into account energy efficiency consideration, among other optimization factors, just to name a few of our research lines. So regarding the need for the next generation computing infrastructure, as well as you all know, we live in an era where almost everyone is connected to the network. This means billions of devices of different kinds, generating a huge amount of transactions across the next generation computing infrastructures. So in order to manage all of this complexity across what we call the computing continuum, considering that the resources available and the energy capacity that we have nowadays is limited, taking into account that, so we need to think about how to better manage these resources. And for that, technologies like artificial intelligence, for instance, will help us to optimize the management and proper usage of resources across the continuum. So most probably you already heard about initiatives like smart computing or cognitive edge cloud challenges that are going to come in the next future. So on one hand, we are going to need, from one side, robust and flexible solutions for handling the large amount of transactions while we minimize energy consumption across the infrastructure. Of course, in addition to other factors like latency or performance that need to take into consideration. While on the other hand, we need to ensure that the data and the metadata is interoperable and secure across the whole continuum. For this, we need to include the appropriate standard, reference architectures, and common ontologies, vocabulary, and data models to make it happen, with the ultimate goal at the end to allow secure and smooth data sharing across the continuum. We also need to take into account that in some cases, this data sharing needs to be done cross-sectorial, but also cross-border. So in a summarized way, these are, in my view, the main challenges foreseen for the next generation infrastructure.
Thank you very much, Enric. And now then we move on to Eduardo. Eduardo, the floor is yours if you want to start as well with your opening statement. Thank you.
Okay, so hello everyone, and thank you very much for this invitation. So I'm Eduardo from the Barcelona Supercomputing Center. Those that do not know BSC, is a high performance research center in which the main objective is on research on HPC systems, in how they are developed, they are designed, and they are built. And as part of this research, we are also trying to push the technology we are doing in the HPC domain to other domains. And one of those is, for example, a one that we are discussing today. So meaning how we can build, how we can design this compute continuum concept that my colleagues before has been explaining and has been presenting. And specifically, something that is fundamental is to really understanding what are the benefits that the different components, the different elements of this compute continuum concept is bringing when dealing with huge amounts of data. So my colleagues has already talked about cloud computing, has also talked about edge computing. But something that in my opinion is very, very important is understanding two things. So first thing is, what are the requirements of the system we are building in terms of privacy, in terms of energy efficiency, in terms of yield time. So the different functionalities, the different services that my system is providing when dealing with data is placed in the right thing, in the right place, either in the edge or in a cloud. But there is also the property of the data per se. The data may be needed to be consumed, to be processed with certain properties that the compute continuum concept needs to provide in a simple way. This is one of the things that we are BSc is actively working on. So how we can distribute the different analytics that are going to incrementally analyze a data across the compute continuum, taking into account the different data properties like privacy, security, real time, etc., etc. There is also another important challenge that I think we should focus on. We are talking so we have a very clear idea of what is the business model of cloud. In the last 10 years, industry has done an excellent work in order to provide all the abstraction level that is needed in order to everyone to have access to it, to develop their services on top of it. But it's not that clear how the edge computing is going to evolve. What are the virtualization layers that the edge computing needs to be provided? So it is offered to people to build on top of it their services. And how we connect edge and cloud in a unique way. So giving this real sense of the compute continuum concept. So in that regard, BSc has been responsible of the European project, the CLAS European project that recently finished, in which we have been researching on different ways of providing this unique compute continuum concept, in which a data analytic workflow is executed, providing a unified framework that is responsible of distributing the different data analytics on the right place. And this is, in my opinion, one of the challenges that we need to focus on, and I'm going to be happy to discuss in this panel. Thank you.
Thank you very much, Eduardo. And now, Roman, if it's okay with your audio,
Yes,
then I can switch to you. Thank you very much.
Yes. Good morning, everybody. My name is Dmitri Roman, and I work for Sinte, which is a independent research organization in Norway. So I come from a more data management background, and our involvement with data spaces has been in developing data services in the context of data spaces. For example, we had a project on building a maritime data space here in Norway for exchange of data between ships and onshore organizations. And I'm also a coordinator of a project called Data Cloud, which deals with the life cycle of data pipelines on the computing continuum. So my take on data spaces and this infrastructure is twofold. The supporting infrastructure is twofold. So one aspect which is very essential is related to provisioning of the data in the context of a data space. So by provisioning the data, I mean what kind of data, how the data is collected, processed, and packaged for the exchange phase. So the essential element here is how can we ensure that data has a certain value before we actually start to exchange it in the context of a data space. So what we see here as new elements is, as was mentioned, this computing continuum aspect, where data is basically both generated and processed on the continuum. So that means that data is, when it comes to be exchanged, data actually comes from cloud, edge, fog, possibly HPC infrastructure, and so on. And not only that, it's a heterogeneity of data sources, but also data has to be processed, packaged, provisioned on this heterogeneous infrastructure. So in this context, we see the notion of data pipelines as being essential, and building services to support different phases of data pipelines as very essential aspects. So there are all sorts of open research problems related to data pipelines. So for example, how can we discover data pipelines from log files across this heterogeneous infrastructure, cloud, fog, edge? How can we actually help business experts to design these pipelines of collecting data, processing, preparing data, analyzing data before we actually bring it into an exchange format. We also want to execute these pipelines. For example, we want to first simulate whether we have enough resources, the cost of collecting all this data, for packaging, for exchange, how we provision the necessary infrastructure, how we deploy this pipeline, how we adapt at runtime. So here we see the need for an ecosystem in which various stakeholders like business experts, data scientists, resource providers, data ops, those that manage the infrastructure for data operations, and of course data providers, consumers can basically work together and in this ecosystem for managing data pipelines. So very important is the separation of concerns in such an ecosystem. And we need better tools to support this life cycle of pipelines. In this process, we also see that emphasis should be put on the data quality, because the data is really valuable when we can ensure quality of the data, we can ensure traceability of the data. Also here comes this FAIR principles like findability, accessibility, interoperability, and reusability. And from the perspective of managing data pipelines on the computing continuum, we also see this problem of energy efficiency that becomes more and more important. How to manage the pipelines, data pipelines, in a way that it's environmentally friendly. So this is one aspect that we see as important for actually making data available in data space. The second aspect is how to actually exchange this data once it's ready, high quality, provisioned in the data space. And here we see the need for trust mechanisms that have to be in place both at the technical but also legal level. From the technical point of view, there are all sorts of mechanisms to bring more trust in the exchange process. Can be, for example, based on privacy-preserving computing techniques like multi-party computation, but can also bring elements of blockchain for transactions of the data and so on. And of course, in this process of exchange, I think data marketplaces can play an important role in this process. So again, to reiterate, our view is that we need better techniques, approaches to ensure availability of the data, making the data ready for the exchange. And the second type of things that we need are related to the exchange of data, more trust in the process, both at the legal and technical level. And that will, of course, come with the need for improving the technical skills of all the stakeholders involved in the process. So we also see that education and skills are important aspects of this new emerging paradigm. Thank you very much.
Thank you very much, Dmitri, and thanks everyone for their opening statement. And I would ask now our panelists to turn back on their video so we can start, let's say, the proper, more interactive conversation on the relevant topics. I mean, we already seen, of course, in this opening round, the main topics about edge, cloud, IoT convergence, the importance of the data, where they are located for technical and administrative policy reasons, and the various parts of infrastructure and also business roles and stakeholders that contribute to this. So it is, as we know, a complex landscape. We already have a question for the public. So I would like to pose this to you because this is one of the various angles that we have, which is about HPC. Okay, so we have Stefano Bonfa, if I read it correctly. He asked, what about HPC on the cloud to solve the delivering data and analytics in the hub and web territorial space process? And I would also frame this a little bit in terms, again, of convergence. So what is HPC and what is data center and this kind of thing. So I don't know if someone wants to take this question or add some comments on that.
So I would like to take this question. So the first thing I would like to bring to this table is what's HPC. So what is the meaning of HPC? Because people is talking about HPC many times. So from a very classical point of view, HPC is this discipline in computer science in which scientists deals with very large problems, with very large data sets in which they need to, and here I'm talking at a very higher abstraction level, in which they need to distribute this computation in a extremely well-controlled computing infrastructure, in which there are a number of nodes that has been highly optimized, okay, in order to execute in parallel, and you have a very fast interconnection network between different nodes, and you have a system that is extremely well prepared in order to support this parallel execution. If we now move this paradigm, this HPC to our domain, it's pretty similar in many sense, except for you don't have anymore this such a high control of the environment. You have heterogeneity, loads of heterogeneity across the compute continuum. You can have from small devices to medium devices to very large data centers. Data centers resemble HPC supercomputers. You have heterogeneity. You have GPUs. You have FPGAs. You have ME cores, etc., etc. So at the end, it is the same, but just a little bit more complex. So here, there are a number of methods, there are a number of techniques that are currently being used in HPC, and there are a number of programming paradigms that are used in HPC for distributed memory system and shared memory systems that can be applied on it. And now focusing on the cloud, you can perfectly apply an HPC problem into the cloud. But here the question is how your system is going to interoperate with it. So how do you interoperate the different analytics that are executed across the computer continuum with your HPC system that maybe it's using MPI or it's implemented using OpenMP. So at the end, this is really an interoperability problem that we are intensively working on it. But then, of course, there is also the other part is how do you deal with all the abstraction layers that clouds provides, and not only this, all the different paradigms that it's providing, like CAS, like FAS. So how do you deal with it? How do you define a function in terms of an HPC? So these are things that you need at the end to match among them, that you need to look for this interoperability between these computing paradigms.
Thank you. Eduardo, other comments on this question about the role of HPC in the, let's say, the data space's large-scale challenge? Good. So I can then move on other.
Sorry, I would like to comment something,
Please,
Giovanni.
Yeah.
So basically to say that I fully agree with what Eduardo say, but
I saw Dmitri also raised the hand. You're next. Sorry. Yeah, go on, Eric.
Okay, sorry. I agree with mainly with Eduardo say. Just adding that dealing with these abstractions that Eduardo was mentioning is also causing an overhead on the management on the whole computing continuum. So is there a solution that already works for HPC? Probably it's going to be more optimized on this environment with all of these techniques that Eduardo mentioned. That probably could be also solved from the cloud side perspective, but due to the overhead that its management is causing, there are specific situations where it's better to go for an HPC system per se, than to try to cover more computing paradigms from the cloud computing perspective.
Okay. Yeah, clear. Thank you, Eric. Dmitri, so you wanted to add something, I understood, right?
Well, I just wanted to make a point here concerning HPC and data spaces. So I think it will be very much depending on the type of use cases. So in our experience with data spaces has been that it was mainly for automatizing the process of sending data from one point to another. So I mentioned in the maritime data space context, so we did not have the extensive need for very highly intensive computing infrastructure. So it will always depend applicability of this computing continuum to the actual data space, type of data space that will be deployed in practice. So just wanted to raise an issue that use of technologies in data spaces will be very much depending on the type of data space and the need of the data space.
Yeah, thank you. And yes, I think it's a very important point. It also leads to some of the other let's say, angles that we had in mind for this session. So maybe we could really move to that if there are no other comments on the HPC part at the moment. And this is exactly this fact of data spaces are one, but they are also distributed, and they have to comply with different needs from different sectors. So I will refer now and maybe later in this session to an event organized by the European Commission about digital autonomy in the computing continuum, where these kind of questions were raised. And particularly the European Commission representatives really wanted to point out that the folk vision that there is a data space, it's a big thing in Brussels, that all the data goes there, of course, is not at all what the plan is, but it is instead to have a highly distributed but interoperable system of data sources and so on. So from a technological point of view, where would you see that the biggest challenges and enablers are to achieve this kind of perfect balance between uniformity of access and adaptation to the continuum reality? Some data are from sensors and processed locally, as we heard. Others can be moved to a data centers. Others maybe need a specialized HPC node because they have specific performance for a certain data algorithm process and so on. So can you give also maybe a taxonomy or classification of what kind of data spaces would need what kind of infrastructure and hardware? So again, Andreas, you raised your hand, right? So I don't know if it was again for the previous question or this one, but go ahead.
So getting a little bit away from this data space term, of course, when we talk about infrastructure and distributed systems, there's an immense challenge, because when we are really targeting the decentralized approach, and it has been also rightly said by the Commission, we need 10,000s of edges across over Europe at least, and not just any edges. We need edges which are in a shared mode, because anyone can build up an edge on-premise environment. And I'm not talking about the telco edges, which are more for mobile services. I'm talking about processing edges, so small data centers cross over the countries. And this implies also that we need appropriate the physical part of this. It is pretty easy to sketch such scenarios on PowerPoint. When it comes to real infrastructure investments, we are talking about €1 billion in terms of connectivity. And then another challenge is, if you have, for example, a shop floor, some facilities, production facilities across over Europe, well, they collect data, they pre-process data. To some extent, you might have the challenge to move terabytes of data from A to B to C, but not on a 24/7 mode, just for a couple of weeks, for example. So you need this level of dynamic provisioning of bandwidth and processing capacities. And this is not that simple, because if you don't have the underlying infrastructure in terms of fiberglass and so on, it is a huge challenge to get this orchestrated. So interconnection is of importance. Distributed shared edges, which can serve for the shop floor, for the mobility space, for the smart cities. So it must be, there are a multitude, and you need those who are taking care about the management of these environments. So this is, I think, another big challenge. Where do we have all the cloud natives and service entities who are capable to provide an orchestrated environment cross over the countries with a quality of service and this dynamic provisioning? I think this is one of the key challenges.
Thank you. I would hand over to Ulrich, that raised the hand first, and then Eduardo after that. Oh, you're still muted, sorry, Ulrich.
Need to unmute. Yeah, I can only support what Andreas said. before, creating the communication infrastructure is one point. And Andreas and me, we are both coming from Germany. And when it comes to the distribution of, for example, fiber to the home in Germany, we have still a way to go to come to situations where other European countries are already. This is also then true for the data spaces, where we need instruments that data spaces can be operated in the continuum. So in a distributed way in cloud and on edge. And then we have the situation that there will not be one single data space. There will be, I wouldn't say 10,000s of data spaces, but at least hundreds of data spaces. We have, or we are just creating two here in Germany. One is called Catena X, based on the Gaia X concepts, and another one has been realized already called the Mobility Data Space. And a lot of similar data spaces will come up. And Andreas, you mentioned the topic of shop floor communication. And I think here we have quite a good example with a standard which came up for the communication on the shop floor level over the last 2 years. It took years to define the standard and finally to adopt the standard in industry. And this is called Opc Ua, the Open Platform Communication Unified Architecture. That's what Opc Ua stands for. And this open and standard protocol is replacing proprietary protocols which were there before, from Siemens, from Bosch, from different providers of shop floor equipment. In former times, these companies were providing closed source solutions, not open interfaces, not open data models, but the end users more and more forced these companies to come up with open standards for the communication. And I think this example is something which needs to be transferred also into the domain of interoperable data spaces, because we need to avoid that each and every single data space will become a silo, a data silo. We will have a lot of processes in the future, digital processes, which will be operated across different data spaces. And therefore, it is important to have interoperability between data spaces. And again, in the continuum, but also elements to allow to exchange data, to create interfaces between different data spaces. And here, as I'm representing here today, FIDA as well as IDSA, so the International Data Spaces Association, here the IDS connector, for example, plays an important role with the ability to define standards, to integrate different data spaces and to have a smooth exchange of data in here.
Thank you. I think next is Eduardo and then Eric.
Yes, I would like to emphasize what my colleague Andreas has said about the challenges of creating such complex and large edge infrastructure. This is, in my opinion, the next challenge from many different angles. And in fact, Andrea has already mentioned many of them. But here, I would like really to focus on which entity, which company is the one responsible of installing and managing them, and how these edge devices are then offered to developers so they can build their services to then have access to the different data spaces. And here the issue could be that we may end up in a situation similar to the one we have in the cloud, in which there are few companies that are controlling all the cloud business: Amazon, IBM, Microsoft, etc., etc. So how this business model can be built such that we can create this edge infrastructure without ending up in this having 3-4 big players. There's also the thing that Ulrich has also commented about these standards to communicate. We also need standards to build services on top of these distributed data sources. This distributed edge infrastructure. Here, I think we are in a better position because most of the technology used in the cloud, that luckily most of it is open source, can be used as a reference point in order to be bring to the edge, in order to deal with it, in order to ensure this interoperability among the different services that will run on it and will have access to the different data spaces. So to me, these two are who is this, or how do we organize in creating these edge devices, this network, highly distributed network of edge devices, and how they are orchestrated. These are two of the most important challenges we need to deal with.
Thank you, Eduardo. And Eric, you're next.
Yeah, very short comment. Usually when we talk about this cloud or computing continuum, we are assuming that we are able to move resources around, scale them up, scale down. So the computation process is done all around over the world, and we can move them, etc. But usually we forget about the data should accompany this execution of the resource. So there is also a lot of challenges in how to move the data, where to move the data, and when. So if it is needed to be replicated or not, you have to establish some kind of synchronicity mechanism, because, as you know, we live in a real-time world, let me say like that, where you can be processing some data while at the same time you are producing in real-time data that you are willing to process. So keeping the synchronization between these distributed data spaces that we are going to need to compute afterward is also crucial for, as one of my colleagues say, have this data pipeline interrelated with the infrastructure pipeline and where it is going to be executed. And in this sense, also the regulations are also very important, because as soon as we are moving data, some of this data needs to be probably obfuscated or encrypted in some way, or different regulations could apply depending where you are processing the data. These are for sure things that need to be looked carefully in the next research area.
Thank you, Enrique. And I saw now also Dmitri wants to add something, so please go ahead.
Just very briefly related to this discussion on where data is and where data is processed. So I think a very important concept here is the so-called data locality in this computing continuum. And we have done some work recently on pipeline engines, taking into account the locality of the data, and that has become a very important aspect in order to be able to properly process data that is distributed and comes from all these heterogeneous devices from edge cloud, whichever devices are out there. So just want to point out the notion of data locality and ongoing research around data pipelines that are data locality aware.
Yep, thank you. That's also absolutely a very, very, very relevant point. And I wanted to pick on a few things that I heard from your last round. In particular, I think that Andreas mentioned this vision of 10,000 edge nodes that is from the Digital Compass, I think, document from the European Commission. And the interesting thing is that if I remember correctly, that document doesn't just say 10,000 edge nodes, but 10,000 climate neutral edge nodes. So which brings us to the topic of the twin transition and sustainability and environmental impact of these things, because we know that while moving to the edge is very good for data sovereignty or data locality, there is some gap in terms of energy efficiency, because the large data centers somehow they have had time to improve their let's say, around the carbon per flops or anyway, the environmental impact for the computing and data power that they have. So question for you all would be, where do you see the challenges and where do you see the synergies between this drift towards decentralization and the need to also keep the environmental impact in terms of carbon, but also in general, of IT under control, which is these are big priorities at the moment.
Yeah, probably I can start on this topic.
Thank you.
Just to reflect, of course, we are getting more and more complaints about the sustainability of data centers, because this is really something where there's room for improvement, and we need to be very careful about the energy consumption. But on the other side, where are we without the digital data centers around us? So what is, for example, the net impact just to reduce the travel expenses and the waste of energy by moving people from A to B and using this facility as we're doing right now to have a video conference and to share our thoughts with a much less carbon footprint than meet in person. So when and this is also when it comes to the edge and the cost, of course, there are a lot of initiatives like Open Compute and so on, where this questions around sustainability and energy efficiency is really on the highest priority. And but on the other side, just consider the building of a data center costs around 100 million euro of a large hyperscaler data center, and you need some guarantees for investments. So whatever you do, it must be balanced. You cannot just complain about the energy consumption. But for example, if you have such an edge scenario, which is more into to support circular economy and to support optimization of supply chain and so on and so forth, I think the positive impact is much higher than the cost to establish such infrastructures. So at least this is my thesis here.
Thank you, Andreas. Any further comments on the sustainability and energy impact? Yes, Dmitri?
Yes, I'd like to mention a couple of things. So I have seen in the last year quite an exponential growth on scientific publications around energy efficient computation. So I can give a couple of examples. There is one initiative which is called Green Algorithms that is trying to measure the impact of running algorithms, the CO2, the carbon footprint. So just an example here, they say that the main factor impacting carbon footprint is the location of your servers. The same algorithm will emit 74 times more CO2 if run in Australia compared to Switzerland. Or that a big impact will have the allocation of the memory, not the actual use of the memory that your algorithms use. There's also a lot of work around predicting energy consumption and carbon footprint of machine learning, deep learning algorithm. So there's a lot of work going on in trying to actually measure the carbon footprint of various operations related to the data. And again, I come back to this notion of concept of data locality that has a huge impact on the CO2 emissions. So I think we need more working to be able to somehow objectively measure the footprint of all these computations and finding smart ways to reduce the energy consumption by taking into account this data locality and making our data processing locality aware.
Thank you, Dmitri. And I see Henrik also wants to add something. Go ahead, please.
Yeah, a small comment. If you remember, Giovanni, in the digital economy workshop that you earlier mentioned for this session, the Commission asked us in the scope of open source software to look as well beyond the kernel level, beyond the operating system, because at the moment we are doing a lot of optimization at operating system level, let's say, and on the services that are running on top. But there is a lack of this optimization beyond this kernel level. So they are encouraging to increase the programmability of hardware devices. And why I'm linking this with the energy efficiency? Because in fact, this is something that we are working on in Atos. As you know, we have pulled at the delivery as a product Opc Ua as a device. And it's really interesting for us to look how we can also optimize the hardware when application is running on top of it. Because take into account maybe just changing the clock cycles of the machinery, we can reduce a lot of energy, or we can adapt it when let's say the resource is not heavily used. And in the same sense, there are also a lot of research challenges on heterogeneous hardware device. So not everything needs to be deployed on the digital GPUs, but GPUs and FPGAs can do also sometimes their work in a more efficient way, let's say, because they are consuming less energy for the same processing task.
Thank you. And I see Eduardo also is next. Thank you.
So here I want. I've heard this discussion a lot about whether the edge computing will improve the carbon footprint compared to cloud only solutions. And while I tend to agree on this fact, something that we also need to take into account is that most of the models that are intended to be used at the edge level in order to quickly understand or to quickly process a data needs to be trained first. And training is a very costly operation that needs to be done at the cloud level or at the data center level. And the fact that data sets, these large data sets are going to provide tons of data for these training operations. So we will be able to create more accurate models, are going to increase as well the pressure on the cloud. So here is important to also take into account that part of the edge computing needs to be backed at the cloud level or at the data center level, especially when training and creating those models that then can be executed in GPUs or even in FPGAs that are extremely efficient. But please do not forget this cloud part.
Yeah, agree. Thank you. And Andreas, I see you also.
Yeah. In general, and we are still talking about sustainability and how to deal with data models in a decentralized way. And I think we should be totally committed. Yeah, we have to be serious about efficiency of systems, but on the other side, we need to be much smarter than we did so far in terms of data management. And Eduardo rightly made the point, when we are talking about tons of data, it is totally nonsense to put everything into a hyperscaler data center to process there, because it is already costless and we have a lot of constraints in terms of bandwidth to move data in this sense from A to B. So we need this smart optimization of data in the edge, reduce and really consider what is the purpose of the data. And this is something we have to do with GDPR anyway. If you don't have any evidence why you process data, then it's a failure by default. So we need to understand how to make value out of data, how to aggregate them, and how to provide them via data marts. And probably we leave the data where they occur, and we also consider, as I mentioned, more computer to data. So, which is where are the good algorithm to take additional information out of data wherever they reside. And then we are coming back to this AI question: can we even optimize such algorithm in terms of energy consumption or resource consumption in general? So we have to take all these aspects into consideration to have a very good environment. But also one of these statements is, in the near future, 80% of the data will occur in the edge. So it will be even worse in terms of data management. So we need the edge for sure. And we need smart services in the edge who are capable to deal with data in terms of optimization and prepare the best out of data for those who are interested into can process into, again, then probably back-end hyperscaler or large data center environments when it comes to AI and HPC and all these things.
Thank you. So if I may try to sum up the various, let's say, points on this tricky sustainability versus decentralization balance, it seems to emerge that the problem is very complex and it has different angles. And so while by default, the economy of scale of the data center is not obviously replicated in the edge, there are so many other ways that we are investigating, from hardware, software, co-design, we heard, or smart data location compression, or even, I agree, and there's smart deletion of data, because why keep them if you don't need them? And they actually are noise for the enterprise. So there are a lot of points there, and this is certainly very, very relevant. And I may also add that beyond the green algorithms, I also heard about green routing, so that if the nodes can document with some smart grid where the energy comes from, if it's renewable or not, then the routing of this big data transfer could even decide where to send the data in a way that the network path has a lower carbon footprint. Now, this is all, let's say, intellectually stimulating, and as I guess most of us know, this is at the moment applied research and innovation area, but the international data spaces are also, I mean, they are more concrete than that, right? They are in Digital Europe, they are already being implemented, and the infrastructure that they need is big and expensive in general. So I wanted to mention the point of the open source software, but also more than that. And this was another point that was made by the Commission and the speakers in this event on Digital Continuum, that open source adoption and contribution seems a very important strategic action in Europe, not only for cost and digital autonomy, but even because there are some studies that says that can even be correlated to GDP increase, right? So what is your view on open source software, but also, as we said, sometimes hardware in this how can it help and how can be leveraged for the data space? So sorry, Andreas, I give the floor first to Enrique. I don't know who raised the hand first, but you just spoke. So first Enrique and then Andreas.
I think Andrea raised it in the previous question, right?
Okay, sorry. So, then great.
Yeah,
it was still up. Yeah, good.
As you know, Giovanni, because we are coordinating Hub4Cloud, recently in the scope of this Hub4Cloud CSA, We conducted a survey across several EU projects of their ICT 14 and ICT 40 topics, where we asked them about their positioning on the different open source software and standardization initiatives. And we found that all of them are somehow involved in the existing open source communities or initiatives, and they already have credible plans for contributing to them. So about the question if the open source is going to play an important role, the answer for sure is yes, because for them, the research objectives, they see open source as a mandatory enabler for building their platform and for accelerating their research. While on the other side, I mean, on the industry side, the use of open source software is in their daily basis, as most of the technology enablers and techniques on the current cloud ecosystem are already also based on open source solutions like Linux, the Red Hat portfolio, Kubernetes, Linux containers, community like the firmware that we have a representative here, are pushing toward all of these open source solutions to make them robust and all. So open source, at some extent, can be seen as an standardization instrument available for the industry in that sense.
Thank you. And then Ulrich.
Yeah, the challenge we are talking here about to create a next generation of computing infrastructure to support data spaces is a challenge which cannot be solved by one single company or just a small group of companies. And here, open source is providing a very good platform, a very good ecosystem to have different companies joining their forces and providing solution for such challenges. And looking at the different main players which are together here, Gaia X is completely committed to open source. We talked about the International Data Spaces Association. For IDSA, it was created 6 years ago. It was not really clear to go into the open source direction at the beginning, during the first 2 years. But then it became clear that to really reach a global adoption of this technology across different verticals and industries, it is important to go also into this open source direction. And 5R itself had a similar history. The 5R story started 10 years ago in the Future Internet PPP of the European Commission. And only 2 years later, the Commission requested the partners to provide the results of this Future Internet PPP as open source. And for several of these partners, I don't want to mention names now, this was too early for open source. So in total, 5 big players, really big players from Europe, left that public-private partnership at that time because they were not ready for open source-based solutions. But I think times have changed, and we have a common understanding that to be able to solve these challenges we have here, we need an open source-based approach.
Yes, thank you. Then I hand over immediately to Eduardo.
Okay, so to me, there is no doubt, and my colleagues has already said this about the importance of open source. But to me, it's more important creating community around open source, and this is the really key enabler that makes open source to be something useful and from which you can take value. Because if there is no, I mean, one of the risks of open source is then there are many projects that does more or less the same, but in many different ways each, and you are ending up creating a silo. So to me, it's fundamental, this community, and there are many examples that that it's also viable from a business point of view. You have Linux, you have Kubernetes, and you have many open source projects upon which there are lots of companies that are taking benefit of it. So I would really like to focus on more, not only in the open source, but on how we create communities around these open source projects.
Thank you, Eduardo. That's also a point we can talk about also in the following, but please, I saw Dmitri also, you raised your hand, so go ahead.
Yes, so of course, open data is an important aspect. It comes with cost reduction, openness, traceability, and so on. But I'm not so sure that a data space will be more successful if implemented on open source than not. So I think, of course, open source comes with its own challenges like good documentation, reliability, and so on. To me, it's more important when it comes to the open part, it's more related to the data, like open standards for data formats, open APIs. I think those are more essential to data spaces to be under this category of open than actual software that will run this exchange of data and publication of the data and so on.
Okay, thanks. And this also connects to another point that I wanted to raise, which is the relationship with standardization efforts, right? And I thought that Ulrich already raised his hand. So maybe, let's say, we can have another round if you have something to add about standardization, or let's say how to achieve interoperability, if not through open source.
Giovanni, I just wanted to add that from my perspective, it is important to differentiate between open source on the one side and open standards on the other hand. It is possible to support open standards also with closed source software. And the open standards are the instruments to create the interoperability of different data spaces when talking about data spaces. And these data spaces might be created based on open source or closed source, but the open standards enable the interoperability of them. So I would prefer not to put both into one bucket. These are two different things.
Yep, agreed. And unless there are further points about open source and open standards, let's say dialectic, I would like to, when we just looking at the time, we have a little less than 15 minutes to go. And I'm already very impressed with all of your contribution, and we managed to quickly, travel through technology and requirements and different infrastructure. And we even mentioned now the community aspect, because open source that nobody uses loses a lot of its power, and we need consensus from a policy point of view and from industrial strategy point of view. So. And there are many associations, not only BDVA that is hosting this whole event, but you around the table here are representing many, and now there are also associations of associations, right? So I wanted to ask you all, let's say, what do you see the value of communities and how to organize them towards these data spaces? How to build consensus. And I think for the one of you that are members of this new Data Spaces Business Alliance, so if I understood it correct, GaiaX and also Fireware and also the IDSA, they are members. So in this case, I would also like to understand how your organization participates into this alliance. Is there already an agreement of how to split, let's say, the focus and work within this new business alliance? This is particular, I think, for Andreas and Ulrich, but in general, to everyone, I would like to hear what you think is the importance of community and consensus building for these data spaces effort, assuming that somehow the technology can serve them and the data is available from the providers to a certain extent. How do we make these things really to catch up, not to be adopted on the larger scale.
Mm-hmm.
So I can just start on this topic, and then I think Ulrich is the perfect guy to elaborate on this. First of all, it is very important that such stakeholders who are taking care to build up such ecosystems are working closely together to avoid redundancy and to bring out the best of all these initiatives for the future evolution of data-driven ecosystems. Well, we all know that Gaia X is the newbie here in this scenario, but it's evolving pretty good in the terms to scope on this ecosystem approach, which is more a kind of overarching orchestration of a multitude of actors. And in parallel, we have this data space initiative to deal about data and business models in the first place. I think this is very important. We need to show the value of such data spaces and why we should why we should take care about these concepts. And I think Fiverr is the best player in terms of building open standards, the integration of a multitude of services and applications, and what is all needed to link all these systems together. And then we have BDVA with a deep knowledge around how to deal with data, how to evolve data-driven business models. So this is the good thing. The other thing is, for each of the associations, it's pretty hard to rebalance with the technology stacks of the others. So this is, I think, the challenging part. Who is now the owner for which pillar of these overall ecosystems? And I think this will still take some time to get a good balance and to adopt these emerging technologies and also the standards, because if we don't have appropriate standards like Opc Ua, like asset administration shell and all the other things, it will be a huge failure, and we will lose the engagement of the SMEs in Europe, which is one of the key entities to drive innovation, because this was one of my key statements that without the SMEs who are really looking forward to establish innovation and all the startups and scale-ups, well, where to get the innovation? For sure, not out of the large companies who are really scoping on their core business model on the cash cows. But if we want to change something, we need this more agile approach with the engagement of SMEs, and they need to understand where is my beef in this scenario.
Mm-hmm. Yeah, I can only support what Andreas said. And looking at the X of Gaia X, and I think a lot of you have this, the main structure of Gaia X in front of you. The Data Spaces Business Alliance is mainly focusing on the upper part of the X. In the lower part, we have the federated cloud infrastructure. In the center, we have the federation services. And on top of that, we have the data spaces. And then on top of the data spaces, the business processes and smart solutions. And the focus of the Data Spaces Business Alliance is on this upper part of the X of Gaia X. And like the name of International Data Spaces, for example, says, it is dealing with data spaces since 6 years. And also our discussion we are having here is showing that it is not an easy task to create globally interoperable data spaces, and it cannot be done by one organization alone. Although we clearly have to admit the highest political visibility is with Gaia X in this consortium, in the ecosystem. And Gaia X made a rapid ramp start. It's really impressive, being founded a bit more than 1 year ago by 22 different organizations, now having more than 350 on board. That's really rapid growth and shows the demand on the one side and the support which is behind it. And the ambition of the Data Spaces Business Alliance is to join forces, not to do something on top or extra, but to join forces to align the activities with the ambition to reach our target, to create interoperable data spaces, bring them to market, bring them into the productive use faster and with less effort as we would spend if we would do it independently. And again, is this an easy task? Is everybody already committed? Is everybody on board of this vision? No, clearly not yet. So it will be a way. It will be a lot of work to make this possible, but I at least personally see a large potential in this endeavor. And the Data Spaces Business Alliance is combining the competence, the know-how of more than 1,000 members of the 4 different organizations. And if we succeed in joining the forces here, I think it will really make a difference in creating interoperable data spaces for the future.
Thank you very much, Ulrich. I would like to, now we have 10 minutes, so it's just a quick answer that I'm asking now. But we have a second question from the audience that is actually pointing out, you said, Ulrich, that we need to proceed faster. The guy actually very quickly, and this is also timing is also an important factor. So I'm reading now the question says, another challenge about standardization for data interchange is to meet market speed. When a standardization of data is needed, you cannot wait for a standard to emerge 1 or 2 years down the line, but of course, market actions must be faster than that. So he asked, or she, the person asked, what will be the data spaces offering to tackle this issue? So if you all have, so this was from Alberto Abella. So thank you, Amrita, for the information. So if you have some quick point to make, what is the value of the data spaces in timeliness?
If I may just continue here, we will definitely not have the time to wait for formal standards standardized by one of the standardization bodies. Our approach is more to align on a common framework architecture on the one side to give the frame, then to align on different building blocks within this architecture. And here APIs, data models, for example, play an important role as as building blocks, and then to develop them to be adopted on the market as a de facto standard in the first step, and in parallel to drive the formal standardization process. Otherwise, I would agree with the question, if we just rely on the formal standardization processes, this would not be fast enough.
Thank you, Ulrich. Maybe I can call on Dmitri, that you mentioned the Open Standard Organization, and I imagine you are well aware of the timing, so maybe you have a specific point to what kind of fast track would you use, or how to combine the openness of the standard with the
yeah, I'm not sure there is there is such a thing as speeding up when it comes to data modeling, data structures. It's a very time-consuming effort to, agree around, what structure should the data have. This comes also from the area of vocabularies and ontologies for data, which I think are very important. There are standardization bodies like W3C that is pushing a lot on data structures. So I think organizations like W3C have a good approach to standardizing data languages for how to specify languages. And also there are all sorts of other initiatives like Wikidata or schema.org that play an important role in standardizing data structures in an open way that are, of course, very relevant for data interoperability in the context of data spaces. So I think that's the way to go to. But again, standardizing ontologies, vocabulary is not an easy task. There are so many perspectives on the same data concept that so I don't have any solution to speed up the process, to say so.
Very good, then, yes, and I don't think anyone can deny the complexity of the task that if they tried it, so that's certainly a very important point as well. So we have 4 minutes to go, so we have to start wrapping up. And I think we went through various angles of the problem, and this was, I think, pretty fruitful to hear you all discuss these points. I would say maybe for the follow-up, I would ask Amrita to post on the chat for every attendee the relevant social media channels and website for the Hub for Cloud and H Cloud projects that we are coordinating this cloud initiative of coordination of engagement. And maybe if we can really do it like a TV style, so that you like answer like in seconds, what you expect next on the data space. So what for each of you, what is the important next step that has to occur now to advance the path towards the interoperable data spaces in Europe, or infrastructure to support them? And maybe we go again in the list. So Ulrich first, then Andreas, then Dmitri, then Enrique and Eduardo, like at the beginning.
I can only underline what I said. Next, and we have not finished to do so, is to align the forces of the relevant players in Europe creating data spaces. And if we are able to do so, I'm really convinced that we will be able to speed up the creation of interoperable data spaces and to create value based on these data spaces.
Thank you. Andreas?
Yeah, we should overcome endless discussions and build another sketch. We should really scope on industrial deployment for data spaces to show the value, and hopefully in conjunction with the upcoming IPSE CRS, the infrastructure program, to build up this cloud edge continuum and to invest into the hardware and the systems, because without them, it will not work at the end of the day.
Very good. Dmitri?
From a usage point of view, I'd like to see kind of easier to use both technology and processes for setting up and using data spaces.
Very good. And Enrique?
I would like to take this one statement made by some of my colleagues before, saying that currently there is no one solution that feels also. We are in a competitive world, forced to collaborate. So we need to be sure that we can make it interoperable. Yeah, that's it.
Okay, good. And last but not least, Eduardo.
Here, I think one of the key elements would be to identify those domains in which data spaces are fundamental. And there are a number of them: health, city, from which I think we can relatively easily get solutions for it. So I think that's the kind of the next thing I would really like to see.
Very good. And yes, it's particularly fortunate that we closed exactly on this, because I wanted to point out the verticalization aspect that we just mentioned. So data spaces is not one big box, but there will be sector specific. I think already today, there are already 2 information days on data spaces, one on agriculture, another on mobility. So there are, of course, things are moving in the specific sectors to advance the vision, but all these verticals, they have to rely on a stable and interoperable base that is domain agnostic. And with that, I thank you all once again. I thank also the attendees, and we wish you a great continuation of the event. And now we just close the session to hand over to the next in the program of the EBDBF. Thanks again to everyone, speakers, attendees, and support
Thank you very much.
colleagues. Thank you.
Bye-bye.
Thank you. Bye.